In this video, we're going to look at resolving a force into components on an inclined plane. These are one of those questions that looks tricky at first, but once you get the angle right, the rest is just trigonometry. The question reads, a particle is at rest on a smooth inclined plane that makes an angle of 25 degrees with a horizontal. A force of magnitude 6 newtons acts on the particle at an angle of 15 degrees to the horizontal. Find the components of the force that act parallel and perpendicular to the plane. Here's a diagram with some of the information from the question. So we need two things, the bit of force that goes along the slope and the bit that goes into the slope. So the first thing we need to do is work out the angle between the force and the surface of the plane. The slope makes 25 degrees with the horizontal and the force acts 15 degrees above the horizontal. So the angle between the force and the slope is 15 plus 25, which gives us 40 degrees. In the diagram, the angle of the slope gets carried across to the force direction, so we end up adding the two angles together. The angle I've written in green, 25 degrees, comes from the alternate angle theorem. Now I'm going to resolve. For the component parallel to the plane, that's a part of the force acting along the slope, we use cosine. So force parallel equals 60 cos 40. I get 40.60 newtons to three significant figures, and that acts up the slope. For the component perpendicular to the plane, that's the part acting into the slope, we use sine, so force perpendicular equals 6 sine 40. That gives me 3.86 newtons. The important part here is taking direction into consideration. I'm taking away from the plane as the positive direction, but this force is pushing the particle into the slope, so this component is negative. So force perpendicular equals negative 3.86 newtons.